Thank you for the opportunity. Let me introduce myself first. I am Manaman. I come from the Bioinformatics Research Group, Department of Chemistry, Universitas Indonesia. This presentation supervised by Prof. Usman Smufren Tambunan. Today, I'll talk about how to detect the Omicron variant of SARS-CoV-2. This presentation started with PCR, the most used method to detect SARS-CoV-2. Next, I'll talk about SGTF and how we can differentiate the Omicron variants by using SGTF. Let's talk about RT PCR for SARS-CoV-2 detection first. RT, or reverse transcriptase, is an enzyme used to generate complementary DNA or cDNA from RNA. This enzyme is used by viruses like HIV and hepatitis B to replicate their genomes. Polymerase chain reaction is a very powerful tool for qualitative evaluation of nucleic acid due to its high efficiency and convenience. Together with the reverse transcription reaction, the PCR method has been widely applied to the quantitative measurement of DNA and RNA messages. Current diagnostic tests for the SARS-CoV-2 pandemic use nucleic acid, antibody, and protein-based detection, but the viral nucleic acid detection by RT-PCR remains the gold standard. Several materials were used to conduct RT-PCR. RNA obtained from the sample, buffer, the NTPs, and specific primers. Primers serves as the initial foundation for DNA replication. There are two ways to perform RT-PCR. The two-step RT-PCR method is required to convert the RNA into cDNA first. On the other hand, the one-step RT-PCR method combines reverse transcription and PCR in a single tube and uses reverse transcriptase as well as DNA polymerase. The primer used to detect SARS-CoV-2 is different in each country. In the UK, the primer used in RT-PCR is S, N, and open reading frame 1A begin. And in Jakarta, the primer used in RT-PCR is N, E, and RDR pigeon. Here we'll talk about the RT-PCR limitation. First is false negative result may occur because of viral evolution. This is because results from real-time RT-PCR using primers targeting different viral genome parts. The result could be affected by viral RNA sequence variation. Second is RT-PCR is expensive. And third is slow to deliver. In this presentation, I am focusing on the first point, the false negative result. Most mutation occurred at spike glycoprotein. The previous study shows that Asgen Dropout already happened before. This is caused by the deletion of amino acids on position 69 to 70. Asgen dropout is a condition where the Asgen primer used while conducting the PCR test cannot identify the absence of sample Asgen. Meanwhile, the other gene was identified by their primers. Previously, the Asgen drop already happened before when the Delta variant spread. Here we can see the trend of Asgen dropout count tends to be increased significantly. After a few months, the Delta variant was spread rapidly. And here we can see the graph of Asgen dropout from several areas in Africa. By looking at the black line, we can see the trend of the Asgen dropout. You can see that in November 2021, there is a significant increase of Asgen dropout samples. This could indicate the Omicron could be replaced the Delta variant that dominates the SARS-CoV-2 variants currently. This is the graph of SGTF proportion in the UK. At the end of November, we can see the proportion of SGTF tends to increase. Cornelius Romer made some calculation to predict the possibility of SGTF will be appeared as the Omicron variant. By Bayesian statistic, we could calculate the probability of Omicron variant from SGTF samples. The P probability of Omicron shows SGTF is equal to 1, means all Omicron shows SGTF. Here we can see the PSGTF non-Omicron from Europe, about 0.05%. P Omicron is really tricky to estimate and it depends on the situation. Cornelius made a wild guess for P Omicron, and by the previous data on the previous slide, he calculated the probability. Based on the calculation, the probability for a traveler from South Africa to test positive with SGTF in Europe is about 99.5%. It means there is only one change from 200 that the SGTF is not Omicron. From this calculation, we can conclude that the SGTF is most likely caused by the Omicron variant. However, the sequencing still needed to confirm that the infection is caused by the Omicron variant. By the 26th November 2021, Multi-Ministry Task Force of Singapore announced travel restriction for affected countries or regions. And at 2nd December 2021, there are 2 imported cases Omicron in Singapore. Singapore updated their policies about travel. First is long-term pass holders and short-term visitor with recent travel history to Ghana, Malawi, and Nigeria within the last 14 days will not be allowed to enter or transit through Singapore. Second is VTL or vaccinated travel lane travelers taking on arrival PCR test followed by the supervised antigen rapid test on day 3 and day 7 and unsupervised self-administered antibody rapid tests from 6 December 2021. Third is several countries will be placed as the category 3 from 6 November 2021, such as Bulgaria, Iceland, Ireland, Luxembourg, etc., due to their situation on this country. I think we are going to the summary of this presentation. First is RT-PCR still remains as the golden standard to detect SARS-CoV-2. Second is the SGTF is most likely caused by Omicron variant. Third is SGTF could be used to suspect, but the sequencing still needed to confirm. I think that's all for my presentation today. Thank you for the opportunity and stay safe.